Welcome to the Test Automation Group and the Van QA. I would like to say that the pizza at the back is the courtesy of Tech System as well. They are sponsored the Van QA group as well, and just like everybody else, they are at the back to answer questions. If you guys have some questions about looking for a job, or you just want to see what is the situation of the market is, they're available back there to talk to you. So thank you for sponsoring the Test Automation Group as well. Now, the talk tonight will be about how to select a test automation environment. Since everybody's looking, and the slide went up about the skills, what enticed me in order to write this speech, this talk, is quite often I see postings for the test automation engineers. And the most important skills that over time I've seen that's missing from the list are not in the list. So I thought, why is this happening? What is it going? And that is, most of the people who look for the automation never done automation before. Hence, when they go, the first thing they look for is a tool. The tool that doing the tool to do automation. How does this work? The tool to... Can everybody hear me? Should I use this? No. Okay. What about now? All right, so I thought, what is it that's missing? Hence, I created a speech, so let's see what's happening. So how to select the test automation environment. So why do we need a test environment in general? So when we start automating things, to begin with, the challenge is pretty easy. There's an action, you want to automate it, you go look for a tool, you pick up BillBot, you pick QTP, and said, oh, this is so easy, you turn recording, or you write a couple of scripts and do it. But over time, as the tests starts accumulating, you will notice you spend more time and resources taking care of your environment than actually the action that you, to begin with, consider to be the automation. So that is one of the reasons that we need to think about that. The second reason is DevOps. I will get to this more and more when we go forward. We're dealing with the new environments, the new paradigms in development are becoming more and more popular. And as these become more popular, I'll see more and more companies try to interchangeably using the QA resources for the DevOps and the DevOps resources for QA. So that's another important features that I'll see as a trend. I've seen as a trend. So basically, it's not only building, how can we actually select, and we have to construct the environment for our test automation. There are, in general, the big, huge companies, the QTPs or Test Foundation server that do offer all-in-one solution, but usually people don't use them. Or if they use them, they have grievances, and if they use them, it does not provide everything they want. So most companies goes in the way of constructing their environments. So hence, how are we going to construct this? So what can we take away from this? What am I trying to cover during this? There are people as managers that running the test teams, and some of you are the testers. Hopefully by the end of this presentation, the managers will have a pretty good idea how to plan and budget. What are the things that you have to consider going forward for your automations? And if you're a tester or working in a testing environment, then basically you will look at this and you will see what are the skill sets that currently are marketable or really, really hot out there that if I have it, I should, if I don't have it, I should get it. And this actually is a hint to managers as well, that these are the skills that you actually need to interview for, not just scripting and automation skills. So why we need an environment, but compared to 7, 8 years ago, that we really did not need an environment, we needed the tools. Mostly because the environment is changing. The development paradigms are changing. And with that, test changes. And how we do testing is changing. What are the changes that we're talking about? Agile. You all heard about it. It used to be, it's becoming more and more prevalent everywhere you go. 7 years ago, it was rare placing to see that they were doing Agile. Now it's rare to see a place that they are not at least attempting to do Agile. And with Agile comes continuous integration. Mixed development environment. It used to be people did dev or they did desktop application. Now most companies have to do web development, backend development, mobile development, and this has its own new challenges. So even when we get to the point of just a web development, you have backend developments, you have UI, web browser, and for the browsers, you have multiple browser testing. All of these are added. Mobile. And architectural changes, new architectural changes provide, new architectural changes introduces new challenges for testing. Now your components are distributed, they're all over the place. Sometimes you want to do end-to-end testing, sometimes you want to do isolated testing for a certain service, so that's another problem that we have. So now that we list them, let's go through those one by one to see what specific challenges and changes it requires when the Agile comes in. Well, test-driven development. And what does the test-driven development does? Developers start producing unit tests. It's rare to apply that you go and developers actually like system tests, but most developers write unit tests. And what they insist on is to include their unit tests in the general cycle of tests that's being run. So now you have tests that someone else has written, requires special environment, but you have to integrate it in your system and you have to run those tests on a regular basis. And so that's the number of the times that you run the tests has been changed. It used to be, if you run your test once a day, that would have been enough. But now, most companies that do continuous integration, which is pretty much everyone, they expect most of the tests to run after each check-in. Those are new challenges. You had all night to write your tests. Now probably you have 1 hour, 2 hours max, or 20 minutes to run your tests. And people start complaining. How are you going to speed up these tests to be running? Releases are becoming faster. So even if you don't push out of all of your tests during each check-in, you will end up running most of your tests before each release. If they do the Agile properly, a lot of places actually have seen successfully do release to web every 2 weeks, or even for the products every 6 weeks. That means a lot of tests, again, has to run on a regular basis. So, and then next challenge is the multiple development environment. What are the multiple development? Just the list as I went through them before. And multiple development environment, even if the functionality stays the same, requires the testers to create multiple test environments to do their testing. So more tests. And architectural changes. Environments are becoming increasingly complicated in order and complex to set up and run. It's rare to see a product that only has one component. Most of them, the monolithical approach it's being phased out. They're service-based. Service-based, that means in order to get one functionality going, you're running multiple services running. I personally work in places that they had over 60 or 70 different services running. If they shut it down, they didn't know how to bring it back up. And then the testers still needed to test this environments. The services are being distributed. There are companies that they run some stuff on the cloud, some of them locally, or all of them are in the cloud. So how do you, for some of these services, testing on the cloud, considering the other challenges that I will list, how do you test them? Then databases, again, the databases are local on the cloud, just different components that sometimes we require testing in security and add of anything. You bring the database, you bring the cloud, and then you bring the security on top of that for testing. Pretty big, complicated system. Hence, we have to duplicate this environment in many instances in order to be able to do our testing. So here you go. Now, we're creating our tests. What are the components that each test or our test environment should have in order for a company or for any user to actually benefit from these tests? I've seen so many projects that people come, write some of tests, they run it for a week or two, the tests start breaking, and they abandon it altogether and go away. So what is it missing? What is it that's not there that the most of these automation projects fail? Well, this is my own invention. I came with 3 R's. For the test type to be useful, they got to be repeatable. Reliable, and reportable. And if you didn't get any of these, probably your project will suffer significantly. By repeatability includes a couple of things. One of them, the simplest part is the act of automating it. The other part that lots of time is missed is the test should produce the same result given the same circumstances. I've seen people, for example, doing the fault testing with introducing random values as they do. So today the test fails, tomorrow the test passes. That pretty much renders that test useless because now you get to the second part and you make the test is not reliable. If the tests are not reliable, people start ignoring them. And then after they ignore them, they take them away that they are not using them. And the last one is reportable. Everything we do got to be able to report. Reporting becomes it's a hard part. It's not an easy part. What information to collect, what information to write, and what information to report and analyze. As the number of the tests becomes bigger and bigger, it becomes harder and harder to produce meaningful reports. So all of this clues into the environment that we want to use. So start from the repeatability. The first element in repeatability is automation, that we have to actually automate a certain action. So automation by itself is pretty simple actually. When 7-8 years ago it was the biggest challenge to automate a certain action, and very few tools they did it. Right now there are tons of tools that do automation and they do it actually pretty well. So just automating one action, everybody does it. Selenium does it, QTP does it, Visual Studio does it. So that is the easiest part. Second part is to distribute the test. Now distributing the test becomes the bigger challenge now. Why? Most of the commercial software that we buy, the big ones, they do have limited capability for distributing the tests during the run. But now, QTP being one, Team Foundation Server being another one, most of them are very difficult and fragile to set up. B, when they run, most of them run very clumsily. So people abandon them after a while. The other problems with the distribution is there are very limited number of the software for testing that do the distribution and running the tests, staff being one of them. But if you work with staff, you know that is another very fragile program that requires, by fragile, I mean it comes up, it runs, it does its work, but it requires lots of maintenance and lots of attention as it works. So that's the distribution part. And then running. So running is the next part that we have to deal with. So after you transfer, you have to start running the program. So what is the agent you will use for the program? Again, some applications that this, like QTP and Team Foundation Server, they do have agents that they do that, but they do it clumsily. So that was the first one. So what is more difficult about this? Distributed running. So one other thing about this is that now the CI tool do help with distribution. So Jenkins, BuildBot, or most of the other continuous integration do help for distribution and running. So most of the companies actually use them as a means to distribute and run the test. The problem is they're not really built to run the test. They built to distribute, build, and distribute the builds. So the facility for reporting and logging are missing from them, and they're not as flexible that the testers wants them to be. And they're not flexible enough for change of the parameters or change of the test as the time goes by. Most of them are pretty static in their configuration. No. So assume we did that and we did actually do what we want to do and write our test and we solve that problem. The next big problem is writing tests for the distributed environment. It's not that easy. There's lots of things you have to consider in order to write your test. That's the challenging part. And one of the biggest things that you have to deal with this is configuration. You're going to have a dynamic configuration based on your environment that most of the CI tools don't take care of, so you have to take care of it yourself. How are you going to deal with that? And this is the same one. So now that we know what the problem is, what we want to do, what are my recommendations? These are the stuff that I've done in order to overcome the challenges that has to do with repeatability. Use databases. This will be a recurring theme as I go forward. Every time you hear, I write it somewhere or I read it from somewhere, read or write it to a database. So for whatever purpose that, if it's involved reading and writing, use a database. That helps quite a bit with access in every single aspect as we go forward. Try to write self-containing tests. Now, what do I mean by that? So when you're using I use two simple commercials, two commercial tools. Say you're writing a test in a tool called Renorex. Is anybody here have ever used Renorex? No? What? One. So Renorex has this ability, this very nice ability that when you write the test, you can actually create an executable file at the end. That you can take that executable file and put it anywhere and run it, and the test will execute. It's self-contained. It has everything in it that it needs to run. Compare that to if, for example, you use another tool called Test Complete. Anybody uses Test Complete? Test Complete. So when you use Test Complete, assume you're using Test Complete with the JavaScript. Now, in order to run that test, you actually need the Test Complete JavaScript environment to run your test. So the execution of your test now is tied up to the environment that the test complete provides for you. Try to avoid the situation like that. If you can write the tests in a self-contained way, write them in a self-contained way. Things not to do, and if you have done it or doing it right now, don't feel bad. I've never seen a place that they've never done this. Don't use text file for configuration, for input data, for nothing. This will be the biggest factor that's going to stops you from distributing your tasks and transferring your tests from being the localized test to a distributed test. And on the same theme, you should never use spreadsheets, which actually lots of commercial tools do provide and ask you to do. And never use XML files. XML files, so the most important in all of this is most of them will be localized, will not allow you to access your data and your configuration remotely, easily at least, or simultaneously, which are the things that you need to do in order to distribute your tests. So avoid this, and you have at least a clearer path to distributing your test and run them in a distributed manner. Reliability. So this is another factor that people, most of the people when they start doing the test, they do not consider. So how reliable do you think your test needs to be? Yellow number, percentage. 80% reliable? 90%? Okay, let's see. Assume you only have 100 tests, which is very, very low number. When you start automating very quickly, the number of the tests that you have goes higher than this, especially if you have a team. And assume that your test runs on every check-in, which is a very, very common scenario. So here you go. So 10,000 execution. If your tests are 99% accurate, you get 100 false positives a week per 100 check-ins, a day, sorry. And if you have 25 developers in a team, 100 check-ins are nothing per day. So here we go, 100. So that your entire resources, if your tests are even 99% accurate, your entire resources, or at least significant portion of it, will go to chase the failures that do not merit investigation. So how can you avoid that? One of the biggest reasons of test failures are unreliable environments, meaning something in the environment has configured improperly, or some of the test has modified the environment for a certain action and has not set it back. So building a reliable environment is extremely important. The problem is the tasks of building the environments usually falls in the shoulder of the testers. I've been in 5 or 6 companies. I think every single company in Vancouver has an open position for a DevOps. And they had an open position for the DevOps for the last 8 months. So as a tester, I would recommend just give up looking for a DevOps and learn the minimum sets of the skills that are required to do your DevOps. If nothing else, if you can't get a job as a tester, you double your salary as a DevOps person. So that's a challenge. So yeah, doing this stuff requires sets of skills that usually it's not advertised. Nobody wants us to do it. Nobody says, hey, you have to know Chef or Puppet in order to get a job. But really, if you get it and you know it, it's really going to add to your value. Another set of skill sets there that we will talk about later, I hope, is virtualization. Lots of this, if you're in a cloud, you're using virtualization. If you are in your local environment, you're doing virtualization in order to do your testing, most of them. Nope. And the environment for virtualization is changing very quickly. Thanks to a little program called, little feature called Docker. It's all over the place, allows to virtualize machine, and it actually allows you to virtualize your tests. Meaning when even last year at this time you needed 100 machines to run 100 tests, now you Dockerize it and you can run 40 tests in one machine, which is what I've done actually. The same, it's that direction. So this is another part that's becoming very important for us to learn. Build, there's no way around it. You got to learn the basics of the build. Most of the companies are started using, as I say, Jenkins and build bots in order to distribute. You need to understand a little bit about the build in order to get by. And integration, you got to know how the pieces fits together. You can't just test one piece and say, this is my piece that I'm testing. As an example, you got to learn the principle of queuing, message passing, how systems talk to each other. If you don't, you can't really get that much in depth and create a very efficient environment. So my recommendation again is first learn database. Database does help you to solve some of these problems, which I don't remember how. For the reliability. So how can database actually help you with the reliability? Before we get to the environment, how to set up the environment is log as much as you can in your database. Again, you speak writes, and as soon as you use the word write it in a database. It's centralized. Even if you don't know you need it or not, give it a key, write it in a database. Allows you to go back, and when you decide to do something with it, you can do something with it and get the data that you need. So that is another very important part. If you log everything in a database, forget about local log files. There are lots of tools that do it. Even if you use it like net2log or JLog, all of them, it's very easy to get them to, it's super easy to get them to log to a file. It is not that difficult to get them to log to a database. And I don't care what database, just pick one. And then it's art of writing test codes. Learn the test codes that you're writing. You got to learn how to write reliable code. That's the whole talk separately in itself. But if I want to say one thing about this is use explicit error handling. For those of you who write tests, avoid using exceptions. I was reading an article about Go, the new programming language that Google has come up with and advocates very much. They left exception handling completely out of language on purpose. They provided extra means of error reporting, and they left the exception handling just for that reason, that they say explicit error handling makes your code a little bit longer, but forces you to think how you're going to pass errors and how you're going to log errors, which compared to creating an exception and create a catch-all phrase, hoping that says, oh, the test fails, the exception will catch it, and then I'll figure out what's wrong with it. Well, it's not that simple anymore. When the code executes over 50 different services and it crashes, it's very hard to debug. So explicitly logging, it's much better than exception handling. So these are just some tips to increase your reliability of the code. And for the other ones, learn virtualization. As I said, Docker. It's pretty easy, it's pretty straightforward. They have tutorials online. Microsoft, so to say how important Docker is becoming, I mean, everybody looks at this and says, why VMware or VirtualBox would like to do Docker, because they're pretty much their competitors. But VMware has announced they're going to start support Dockers. Microsoft announced they're going to start Docker. So if there's one thing that you want to, well, two things, this will be one of them, learn how to use Docker and how to compartmentalize your test. It's far easier than you can think. There's a set of commands, maybe there are 20 sets of commands, and they're very easy to do, so get on it. And then if you have some extra time, learn some configuration management tools. Here at Hootsuite, I think they use Ansible. There's Puppet, there's Chef, and a whole bunch of other ones. Pick one. It really doesn't matter which one. All of them do pretty much the same thing, and most of the stuff that you guys want to do. So pick one of these, and the basic features that they provide, the basic downloads for them are free and saves you lots of grief in simple little thing that you think, I know how to do this in a batch file or PowerShell file, and you ended up writing 5 pages of batch scripts or shell script. In Chef and Puppet, you will do it in one line. So really, it will pay if you learn these skills. Next part is reportable. That whatever we do, whatever you record, it has to be consumable. Meaning, your boss got to understand it. It's got to be in the terms of graph and charts. And the best way to do that is put it in a database. If you don't put this stuff in the database, you will not be able to get it. The tests are distributed. They're going to mean if you log them to files, then you have to merge the files. If you put them in spreadsheets, you have to merge the spreadsheets. Create a database, log everything into the database, and then analyze it later. Much, much easier. This is, again, goes back to the fact of how to do it, which is, I said, put it in a database, nothing more than that. Conclusion? Three things for people who are hiring, or if you want to learn something, or if you're looking for a job or looking to increase your salary by having the skills. And if you want none of these and you want to be a really good automation engineer, database. Learn database and learn, that's one of the most important skills you can have. Configuration tools and virtualization. As I said, you know these three. Even if you can't get a job as a tester, you can double your salary as a DevOps person. And they're really easy to do. Docker, you will learn in 3-4 days. Maybe Puppet and Chef are bigger. And I guess we all have taken some database courses in school. So and if you're hiring, you can teach people how to automate using QTP within 15 days. These are the skills that most people, that your team will need, and it's not there. It's not readily available. So that's it. Thank you. Please.
So you said avoid exceptions, but then you have to write the spaghetti code, if else. For the error handling.
Well, you don't have to write a spaghetti code, right? So it depends. You can create levels if you start logging everything to the text file. Yeah, that's what will happen. But you can actually, based on where you are in your you can pass errors up, and B, you can actually log to the database with the certain levels that will tell you where in the code you are. So no, it's not necessarily that you're writing the spaghetti code, but it makes you think about where your error happens. But yes, you're correct in the sense that the size of your code will increase if you don't use exceptions. And I guess there are exceptions to exceptions as well. So, yeah.
I've heard a lot about sort of immutable environments. I mean, whenever you generate an environment, keep it immutable no matter what. If you need to make a change, just regenerate it. And so I guess it comes down to computation speed and availability and all that. Do you have experience in any of that?
I do. Yes. That's a very noble idea to begin with. But the problem that I've run with this is you start generating the environment, you make the immutable environments. You work very hard to speed up the amount of the time that you spend to run your tests. You bring your tests down to running 20, 30, 40 minutes. But your immutable environments now change as you run the test. Your database, if it's embedded, it will change. Your configuration might change. So for the next set of tests, now you have to recreate the whole environment. Now the environments, if you don't use a Docker, 2.5 gigabyte of data has to be generated or copied from one location to another location for you to start running your VM again. Hence, you gain your time in writing the test, you're increasing the time that your test is running, but then you will end up with hour and a half, and I'm really in the environment that I am right now, that's what they do. It takes hour and a half to set the environment up to run the test. So that's the problem with the immutable environment. Now, again, Docker is a good solution to that because now your size of your environment goes lower, becomes smaller to set up, and you can just start a Docker and you don't change your environment. So that's another good use of Docker.
Okay, so the concept is sound. We may not be there in terms of speed yet. We're kind of, it's the beginnings of that.
Well, it's a perfect idea, right? I mean, if you could just regenerate your entire environment every time you run the test, it's great, but...
Okay, good. So
Yeah.
you're nothing fundamentally against
No.
it. Okay.
Yes.
So you said not to use text files, but what if, say, your test consumes lots of data and you need to have that data stored somewhere?
Database. That's an easy question. Database. So,
What if, say, you can't really use a database that's not using this?
again, there are exceptions, but think about why can't you use a database? Or, you mean, your environment, you're talking about an environment that's completely isolated, yet you don't have a networking access?
I do, but then it's not something that can be done.
It is, so, if, again, to answer your question exactly, is if you have to use any configuration file that you cannot separate, the best solution is check it in, put it with the build, so every time that you check out your code, just generate your code directly from your source tree, which includes the configuration.
That's
That,
what I'm doing right now.
I'm sorry?
That's exactly what I'm doing right
Okay,
now.
so that-
I'm wondering why.
So that's a very good solution if you don't have anything else to do. But putting in a database has the advantage that makes it dynamic. You can make multiple versions of it for the multiple environment and multiple tests that usually you cannot do if you have it in a text file. And another nightmare with the text files they become stale when they go to any environment. Now you're getting them from the source tree, and that's good. But if the environment sits there, the text file might not get deleted, the cleanup might not happen, so you're running it with the old file, and that's become a mess. But yeah, there are cases that you have no other choice, but really setting up a database, it's very easy. Try it.
It's not setting up the database, it's just security issues that I can't get past,
Okay,
things like that. Thank you.
no problem. Any other question? Yes.
I agree with your point about logging results to the database. Any tools you can recommend for results analysis?
Yes. Write your own. So the result analysis, at what point you want to do it. So usually when you start logging in a database, you're doing the logging yourself. So it's very hard to determine what we're actually doing this I was doing this today. I think it's called Cube, and there's a series of the tools that conform to the Cube, which is basically you can get, just Google Cube, that you can get, and they require certain fields that you have to generate, and with generating those fields, it will give you the standard results coming back. Now, how flexible they are, it's based on what your data is. But yeah, there are a whole bunch of them. If you give me your email address, we just went through them, I can send you a list. It's called Cube, just Cube analysis.
Thank you.
Anyone else? That's it? Great. Thank you.